Okay, so this lesson comes from Go Math 7.9, in which we're identifying equivalent expressions. And first of all, let me just apologize because I know you see the page is somewhat cut off, but that's okay. You can just follow along on page 283 in your book, and you have the same information. So again, our essential question asks us, how can we identify equivalent algebraic expressions? And that's important that we keep in mind. What we're focusing on today is looking at identifying expressions that are equivalent, or basically that are equal. And they're going to be expressions that are algebraic and not just numerical expressions. The Unlock the Problem reads, each train on a roller coaster has 10 cars, and each car can hold 4 riders. The expression 10t times 4 can be used to find the greatest number of riders where there are t trains on a track. Is this expression equivalent to 14t? And so the question's asking us, is the expression, this is the part that's cut off, 10t times 4 equivalent to 14t. So these are important facts here. We want to also box in the signal word that we know we're looking to find whether this expression here, this first one, and we'll just label it maybe as A, is equivalent to the expression 14t. As we take a look right here, this box kind of gets us ready to solve the problem. The question here that's posed says, what is one property of operations that you can use to write an expression equivalent to 10t times 4? Now, the other day we worked with algebraic expressions or expressions of operations, and we looked at a type of property called the associative property. We looked at the commutative property. We looked at the identity property. And we looked at the distributive property. Now, there might be more than one operation or property of operation that I could use to kind of generate an equivalent expression here, but in this case, let me just look and see if I should do something with the associative property first. Now, there's the term 10t and then there's the term 4. And so because there's only 2 full terms essentially here, although this 10t really is saying 10 times t, let me maybe look at the commutative property. Well, what does that property state? That property, if I recall, states that I can take a look at the numbers or the order of the numbers, switch them, flop them around, and the product in multiplication doesn't change. So that idea of 7 times 3 is the same as 3 times 7. So that's the property I'm going to say I'm going to be able to use here, because I know that with the commutative property of multiplication, in this case, it's saying I can go ahead and reverse the orders or change the order of the terms, and the product would still end up being the same. So now I'm looking to determine whether or not 10t times 4 is equivalent to 14t. This particular expression, 14t, is the product of a number and a variable. I know that because here's the coefficient 14, here's the variable t. So I could write it and rewrite it as I just did using the commutative property, of which I just can reverse the orders. Okay, 10t times 4 can become 4 times 10t. All right, well, that hasn't completely helped us determine whether it's equivalent. Let's see if I can do something else. Let me maybe now try the associative property of multiplication. And the associative property of multiplication really states that, okay, any way in which I group 3 factors is not going to also change the product. So now that I have 4 times 10t, I know that this coefficient 10 is going to be multiplied by t. So let me just pull it almost out by itself, include it in the parentheses. And that's now how I've grouped these 2 factors and then have t here. Well, what's 4 times 10? 40. What's 40 times t? That just means I of 40t. So now you've got 40t. If you remember, I was trying to compare it and see if it was going to be equivalent to this 14t. So original expression had us examining 10t times 4. We wanted to say, is it equivalent to 14t? Well, we did all this to determine that 10t times 4 is 40t. Is 40t and 14t equivalent? Absolutely not. Now, if I wanted to make sure and just kind of check the reasonableness of my answer, well, I could look at the expressions and notice that they're not equal. Okay, but what if I took it a step further and I was able to justify it by saying, you know what, let me choose a value for t and let me evaluate it, these two expressions, as substituting a number value. Well, the number value I'm going to substitute here is going to be 2. So now every t is going to equal 2 instead of just having the t. So let me look. If I have 40t, that t now becomes 2. So 40 times 2, and that's what we're showing over here. And 40 times 2 is 80. And then what about the 14t? Okay, 14t now becomes 14 times 2. 14 times 2 is what we're going to do there. 14 times 2 is 28. And clearly we could see that these two expressions are not equal. Now, I think that that was pretty straightforward for you, but truthfully, you could also use logical reasoning. Let me just throw at you one other technique. Now, if you recall, we can write equivalent expressions if we combine like terms. Well, let's just, again, see the original expression here and then here. Are there any terms in which I can combine? No, because this coefficient and this variable are not like the 4. 4 is a numerical term, and here we have an algebraic term because we have the variable and we have the coefficient there. So I can't just add these two together. There's a multiplication sign there, and plus they're not like terms anyways. So the only way I really could have gotten 14t was if I would have said, oh, what's 10t maybe plus a 4t? Or 10t plus 3t plus 1t? Or 10t plus 2t plus 2t? Any variation to get 4t, but the variable needed to be there, and so it's not reasonable that these two expressions are equivalent. All right, let's take a look at the example on the next page. The next page example asks us once again to use the properties of operations to determine whether the expressions are equivalent. That's what we're doing here. Okay, and I'll go ahead and just kind of highlight that so we can be reminded of what we're really focusing on. So once again, we've got two distinct expressions. One of the expressions is 7y plus x plus 3y, the sum of x and 3y. And then another expression that we're looking to see, is it equal, is it not equal to 10y plus x? Hope you can see that. Let's just scoot it over a little bit. Okay, so the expression 10y plus x is the sum of two terms. So we're going to rewrite this over here, this 3y plus x plus 7y plus x plus 3y is the sum of just two terms. How can we take these three terms and get them down to just two terms? Well, I use the muted property x plus 3y, saying I could reverse the orders, that's fine. And when I do that, that then would say, let me just flip-flop this and make sure that the 3y now comes first, and I have x there. Okay, now can I use another property? Yeah, I could use the associative property, because now I can group them in a way in which I'm going to solve the 7y plus 3y first, right? Because here this parentheses would say to do that first. So you've got it. Now I know I can combine these two terms because they're like terms. When I have 7y and 3y, because they both have the variable y, there is no exponent, so they're like terms, it gives me 10y. And I can't forget about this x that was here. So although these two terms were like terms, I need to remember that x in the original. And so now this 10y plus x is what became of that. And guess what? It looks the same to me. So the expressions 7y plus the sum of x and 3y and 10y plus x are equivalent. The last example, take a look at it for a moment. See if you can think about, what's logical reasoning that I could use right now? Okay, and this expression 10m plus n is the sum of two terms. So it's the sum of two terms. So I'm going to rewrite this 10m plus n, 10 times the sum of n and m. And I'm going to use the distributive property. Because if you recall, the distributive property says you get a 10m. So that becomes 10 times m. You get a 10n. That becomes 10 times n. And so I'm looking at it as being 10m plus 10n. And that's our first term, our first expression, rather. Okay? And remember, we're looking at two different expressions. The second one we're looking at is this 10m plus n. All right, well, first of all, let's compare the expressions that are here. We have 10m plus 10n and 10m plus n, a singular n. Well, let's think a little bit. The first term in both expressions are what? 10m. Oh, we're on our way to maybe an equivalent one? They're the same. But the second terms are absolutely without a doubt different, right? This 10n and this n are not the same. So clearly they're not equivalent expressions, but again, let's take it one step further, justifying our reasoning, making sure we can say our answer is reasonable, because now I'm going to substitute the value m and say, let me make that 2, and n is now going to become 4, as we've been asked to do. So now instead of 10m, it's going to be 10 times 2. Instead of 10n, it's going to be 10 times 4. 10 times 2 happens to be 20. 10 times 4 happens to be 40. 20 and 40 is 60. And now for this second expression, and I'm glad they have a line here down the middle so we can kind of organize our work. 10m, remember m is now 2. 10 times 2, that gives me 20. And n just by itself is going to give me 4. And so when I have 20 and I add 4 to it, it gives me a total of 24. So again, showing and proving that these two expressions are not equivalent. Now in today's lesson, you're going to be asked to simply state whether they're equivalent or not, but I am going to ask you to make sure you show the work. So if you need to use a particular mathematical expression, do that. If you're just going to show the work on scrap paper, do that, but please make sure you're justifying your reasoning and checking that your answer is in fact reasonable, because maybe you're even going to go a step further and say, let's substitute a value for any of the variables.